Hey Martin, sorry that I've run you on a wild goose chase. The command that you created does work beautifully. It does exactly, however, what the deskproto command does. So if you type deskproto on the command line, that's part of the print 3D routine which exists already and will do exactly what your command does. Okay, so what I'm after is deskproto. If you run the deskproto command, it will just open blank. Let me actually run it. Okay. Okay. Come on. Okay, so if you run the deskproto command, I'm going to make it really rough because I don't have time to waste on this evening. Come on. Yeah, man. Alright, so now, see, he's chosen to save it to C users. Go on. C users, or not him, Rhino, somebody has written it into the local temp untitled.stl. Okay, so what I'm after is what happens when you open this. It opens, it's fine, alright, but your defaults have not been applied. It thinks that it's trying to cut an index. If I look at it over here, it's trying to cut an index. It's not even using the rotary axis. In other words, all the parameters required to do a rotary cut over here are missing. Okay, and a lot of users have a hard time every time filling in all the blanks over here, and I think especially new users find it difficult to get their head around all the dialog boxes. I mean, not advanced users, but older users eventually get the hang of how this works. My idea is to try and simplify all of this so that it makes it easier for newer users to get into it. And so let me show you what the hopes of these plugins are. Okay, I'm going to close that, and I'm going to, and I saw there was another one open somewhere. Okay, so the hopes behind why I was scripting this was so that if you look at the code over here, we're saying grab all the objects, alright, and create an STL, which I've put in over there. I've created a temporary folder called, I don't know, dptemp or C program files, cadwax temp folder or milling folder or whatever it is that you want to call it, right? So export that STL. Now it requires the user to grab the right geometry at the right time, alright? So I envisage this working as, let me pull this closed so we can see that. I envisage this working as, here is the same ring, alright? Here it is in its flat orientation for flip milling, cut from the top, cut from the bottom. Same ring over here in its rotary orientation for cutting the rotary pass. So the idea being that with the template that I've written, you can grab this geometry. Okay, I'm gonna grab it now, and I'm gonna type mesh. All right, so I'm going to take us through the commands one at a time. I'm going to type mesh. I'm going to grab it fairly loose because I don't want it to waste a lot of time meshing out. Oops, I didn't want to mesh. I wanted to export as STL. Hang on a second. So I'm going to grab all of that, and I'm going to go export, and I want to export it on the desktop as my flip cut. So there's my, let me delete these guys. Okay, so I'm going to give it a specific name because I've coded my template to look for an STL file called flip.stl on the desktop. So the output file will, for this particular operation, which is the flip cut, the XYZ from the top and XYZ from the bottom, I call it a flip. Terminology may differ between different users. So I go save. Okay, anyway, so we put this on the desktop and it will mesh that out, and it will create a file called flip.stl on my desktop. Or you could save it to any arbitrary place as long as I then code my DPJ project to open it. Alright, so now we've got up to here. We've gone select the mesh, do that, export it. So now there's a command line to run, not just to start deskproto 6. If just starting deskproto 6 was enough, that would be fine, except that it then leaves the user to fill in all the details on how to do this cut. Alright, so what I've done is, with Lex's help, here's two DPJ files, just ones we're testing with. This one is a rotary, it's a DPJ is a deskproto project file. A rotary DPJ is, what I've done is I've gone into deskproto, I've pulled in a ring and I've set up all the parameters for it, and I've increased the parameters width and breadth to take just about any ring you throw at it, and it will cut a rotary pass right around the top. Okay, and the same thing with the flip. So let me show you I've created over here, I've created two versions of what the command line would be that you export from Rhino to start it up with. So currently what you've got, if I look at the properties on this, currently what you've done is you've created that STL and you've opened it in Desproto, all right, which is great. But if you go one step further, I don't know how to open this. If you go one step further, you can open Desproto, all right, and you can specify the project file that you want to open, all right. So you can go, this is rotary.dpj. So when you open Desproto, open it and then open this project file, this template file, whatever it is we want to call it, this file that contains all the information required to do the pathing. And then not only that, when you're finished with that, actually generate the NC code, all right, actually generate the code required for the user to then go and cut everything that they need to cut, all right. So I'm going to show you how that works. Now we've created the STL file, which is rotary.stl. So if we run this, this would be the same as you running this shell from inside the script. Okay, so let's run it. Here it is, rotary.dp. So we're running that shortcut. This is where your work would come in from Rhino. It starts Desproto, okay. It loads the correct DPJ and it starts generating the rotary pass all in one go. All right. I've set this to cut from -180 to +180, and it will cut a rotary pass right around this ring and constrain it to the top of the ring. The reason for that is just the millers would know that you cut from the side, and then you constrain your cut to the top so that you don't have overcut on the side of your rings. All right. So the idea being is that this whole process that we went through now, which originated in Rhino from a piece of geometry here, okay, that ring which is in a rotary orientation for the milling machine, you would go, all right, let's go to Rhino ring and let's go to milling and Desproto. There would be a new sub menu, Desproto rotary, Desproto index XYZ, Desproto index ×2, or index A, index B. So in other words, write a path to cut the top, cut the front, flip the ring around, cut the back. Desproto 4-sided indexing, Desproto 8-sided indexing, whatever it is that your end users ask you or they think is a handy sort of project file to have or a template file to have. The template files are easy to make and they're not really a problem to do, okay. And pretty much all jewelers are using pretty much the same cutter range. So I've already had a chat with Jack. Jack felt there was great promise. Jack is the owner of Minitech. He felt there was great promise in tying a script like this to both Desproto and a hardware fixture and then selling it on. So I hope that I've clarified a little bit what the needs are in what I see this program doing. All right. So if I open, I don't have my Rhino script that I made. So your Rhino script obviously works perfectly. The only difference is we need to be more specific now about that script, and we need to include it in more than one place. So the script has to not only just start Desproto and inject the STL, it needs to start Desproto. I'm going to cancel that. It needs to start Desproto with a quite specific project file based on the orientation of the geometry that the user would then use. You don't have to guess that, but the user would have to know that he's going to do a rotary, or he's going to do a flip, or he's going to do a 4-sided index, or whatever it is. These DPJ files, I've already supplied you with those two, I think, in the last email. If I haven't, then let me know and I will send them to you. And what you would do is, I think the easiest thing to do is just go to my computer. I don't know where your CADWAX is stored nowadays. Program files, is it? CADWAX, not in there. CADWAX in here. Okay, so I'm not entirely sure where it's installed now, but between us we'd figure out. It's called Rhino Ring, is it? I forget now. Rhino Ring. So we go in Rhino Ring and we create a new folder in there. We would call it construct temps, or whatever it is you want to call it, whatever works for you. Desproto temp or something, just so that you have somewhere to send your STL files and I have somewhere to point my Desproto project file to look for those files. Okay, so C program files, Desproto temp. I will write my Desproto projects to look for it over there, and you will write your Rhino code to export the STL to there. Okay, then your Rhino code, the last thing it would do is it will call up Desproto with this command line. If it was if the user used the rotary command, the rotary Desproto command, then this would be a command line for that, and it would output the rotary NC file directly on the desktop. Okay, so Desproto is actually finished running and it's dumped the file on my desktop, and the total user intervention was from start to finish selecting a ring and clicking a button, Desproto rotary. One click, the whole thing finished, and the user is left with a rotary NC file on his desktop. He can go mill, and everybody's happy. Okay, so I hope that was a bit more useful and a bit more explanatory about what I'm hoping to achieve with these. All right, thank you very much for your time, mate. Cheers.